Workface planning. Workface planning is where materials management directly influences whether construction execution is predictable or reactive. While it's usually viewed as a construction planning discipline, its effectiveness is fundamentally dependent on how well materials are planned, staged, verified, and released in alignment with installation sequencing. Without reliable material readiness, even well-defined work packages break down at the workface. From a materials management perspective, workface planning provides the structure that connects engineering deliverables, procurement sequencing, construction warehouse operations, and field issuance into a coordinated execution model. As a foundational element of advanced work packaging, AWP, it defines how material demand is translated into executable installation scope and is released only when materials can support uninterrupted work. When this linkage is strong, material flow is purposeful and controlled. But when it is weak, crews experience issues such as waiting and excess site congestion. Installation readiness is the measurable outcome of this alignment. It reflects whether materials required for installation are not only delivered, but verified, documented, staged, and positioned to support execution in the planned sequence. In this context, readiness is a tangible condition that materials management either enables or undermines. This chapter builds directly on the project supply chain and construction warehouse narratives by extending the same readiness mindset into workface execution. Just as materials are forecasted, staged, and issued to support installation sequencing, workface planning ensures that work is released only when material readiness can be confidently confirmed. Together, these disciplines replace reactive coordination with controlled execution, which allows for predictable and repeatable construction performance driven by material availability rather than material uncertainty. Now, workface planning framework and work packaging discipline. From a materials management perspective, the value of workface planning lies in how work packaging clarifies material demand at the point of installation. Installation work packages, IWPS, provide the mechanism to translate engineering scope into discrete material requirements that can be planned, staged, and issued with precision. When packaging is aligned to how materials are installed, it becomes possible to manage material flow deliberately rather than reactively. Work packages establish clear boundaries for material scope, quantities, and sequencing. This allows materials teams to prepare complete material sets, validate documentation, and stage materials in advance of execution. Without this discipline, material demand remains vague, staging priorities become unclear, and warehouses are forced into last-minute response mode, driven by field requests rather than planned issuance. Equally important, work packaging establishes governance for material readiness decisions. It defines when materials must be complete, who validates readiness, and how exceptions are handled. When this governance is consistent, materials management shifts from chasing shortages to supporting a controlled release of installation-ready material packages. Key questions to ask. Are work packages structured in a way that clearly defines installation-level material demand? Do IWPS provide sufficient detail to support accurate material staging and issuance? Is there clear ownership for validating material readiness before work is released? Do we have the necessary systems and people in place to properly execute? Installation readiness from a materials perspective. Installation readiness can be achieved only when materials are confirmed ready and not assumed ready. In practice, many productivity losses occur because work is released based on delivery status rather than true material readiness. Materials may be on site, but not staged, not kitted, missing documentation, or not aligned to the installation sequence. From a materials management standpoint, readiness means that the material required for a given AWP are complete, verified, documented, and physically positioned to support efficient installation. This shifts readiness verification away from subjective judgment toward objective confirmation based on material status data. A disciplined readiness approach also changes behavior. Instead of pushing materials to the field just in case, the organization adopts a controlled release model where materials are staged and issued only when installation is imminent. This reduces congestion, limits damage and loss, and ensures that material availability supports productivity rather than disrupting it. Key questions to ask. Do we define installation readiness in terms of material completeness and staging, not just delivery? Are we taking the construction strategy into consideration when determining material readiness for fabrication and installation? Are incomplete material requirements treated as release blockers rather than field problems? Material readiness and construction warehousing. Material readiness is the operational bridge between warehouse management and workface execution. Warehouses do not simply store materials, they convert delivered items into installation-ready material packages. This conversion is achieved through receiving, identification, documentation control, kitting, staging, and controlled issuance. In a mature model, materials are staged specifically to support upcoming IWPs. Warehouse kitting and staging activities are driven by work package priorities rather than generic inventory management rules. This ensures that materials are positioned where they are needed, when they are needed, and in the sequence they will be installed. This approach also minimizes excess inventory at the workface. Rather than pushing materials forward prematurely, the warehouse supports a pull-based flow aligned to workface demand. The result is improved safety, reduced rehandling, and clearer visibility into material readiness across the execution horizon. Key questions to ask. Can the warehouse reliably stage complete material sets for upcoming IWPs? Is material readiness visible by work package, not just by item or purchase order? Are warehouse activities prioritized based on installation sequencing, material forecasting, and look-ahead alignment? Material forecasting is what enables workface planning to be proactive rather than reactive. Effective forecasting translates the planned installation sequence into time-phased material demand that can be staged, verified, and issued ahead of execution. In a materials-driven workface planning model, the look-ahead window becomes the critical planning horizon. Within this window, upcoming IWPs are assessed against material availability, documentation status, and staging readiness. Forecasting at the work package level allows shortages and gaps to be identified early when meaningful corrective action is still possible. This forecasting discipline also supports risk management. When long lead items, fabrication delays, or documentation gaps are visible against upcoming installation needs, materials teams can adjust staging priorities, accelerate inspections, or coordinate contingency actions. The result is a workface plan grounded in material reality rather than optimistic assumptions. Key questions to ask. Do we forecast material demand at the IWP level within the look-ahead window? Are potential material shortages identified early enough to influence execution planning? Is the look-ahead plan used to drive warehouse staging priorities? Work release discipline and material-driven execution. Work release discipline is only as strong as material readiness discipline. Releasing work before materials are ready forces crews into workarounds, increases unplanned material movement, and undermines confidence in the planning process. In a materials-aligned workface planning model, work is released only when the associated material package is complete and staged. This creates a predictable cadence where warehouse operations, field supervision, and materials management operate from the same readiness signal. Feedback from execution is equally important. When work stalls due to missing or incorrect materials, those gaps must be captured and fed back into material planning and staging processes. Over time, this feedback loop improves readiness, accuracy, and reduces recurring material-related disruptions. Key questions to ask. Is work release contingent on verified material readiness? Are material-related execution issues captured and analyzed for improvement? Does material readiness performance influence future staging and forecasting decisions? Digital enablement for materials-driven workface planning. Digital enablement is critical, and it is not just a home/engineering office issue, it extends into field activities. It makes material readiness visible, verifiable, and scalable. Realizing the requirement to identify key data, accurately store and report on that data is critical to shift this activity into the 21st century. Without integrated systems, material readiness is inferred through manual coordination, spreadsheets, and informal communication, making it unreliable and difficult to sustain. A strong digital foundation connects materials management systems, warehouse operations, and work packaging into a shared execution view. Planners can see whether materials for a given IWP are received, staged, documented, and ready without relying on phone calls or field checks. Warehouse teams can prioritize staging based on upcoming work packages rather than reactive requests. As data quality improves, digital tools also support forecasting and exception management. Dashboards highlight material gaps tied to upcoming IWPs, enabling earlier intervention. Over time, AI-enabled analytics can identify patterns in material readiness performance, such as recurring documentation delays or staging bottlenecks, allowing teams to address systemic issues before they impact execution. The role of technology is to reinforce discipline. It ensures that readiness decisions are based on facts, that work is released intentionally, and that materials management operates as an integrated enabler of predictable execution. Key questions to ask. Do our systems provide real-time visibility into material readiness by work package? Is warehouse and materials data integrated into workface planning workflows? Are digital tools helping to effectively implement change that enforces readiness discipline rather than adding overhead? Metrics and KP is for material-driven installation readiness. Metrics should reflect whether materials management is enabling clean execution. The most valuable indicators measure material readiness by work package, not inventory volume or transaction counts. Leading indicators include the percentage of IWPs with complete material readiness, aging of material-related constraints, and staging accuracy. Lagging indicators include work stoppages caused by material issues, unplanned material movements, and rehandling. When metrics are aligned to work packages, they create shared accountability across materials, warehouse, and field teams. This shifts performance conversations from reactive problem solving to proactive readiness improvement. Key questions to ask. Are we measuring material readiness as a leading indicator of execution performance? Does governance between materials, warehouse, and field teams create shared responsibility? Do KPIs drive improvement in staging, forecasting, and issuance discipline? Thinking about the future of workface planning from a materials perspective is moving toward predictive material readiness. As materials data, warehouse systems, and work packaging become more integrated, readiness will be assessed with increasing confidence before work is released. AI will play an enabling role by analyzing patterns across material delivery, staging timelines, documentation completion, and historical execution outcomes. These insights will help teams anticipate where material readiness is likely to break down and intervene earlier, improving schedule resilience and reducing expediting. Digital work packages will evolve into living objects that reflect real-time material status. As materials are staged, issued, or delayed, readiness signals will update automatically, allowing planners to adjust release decisions with greater speed and confidence. The ReVisionz advantage. ReVisionz helps organizations strengthen workface planning by grounding it in reliable materials readiness. We partner with teams as they shift from the engineering office to the site to assess current materials management maturity, warehouse alignment, and readiness visibility. From there, we define pragmatic roadmaps that connect supply chain, warehouse, and workface execution. As data quality and integration improve, ReVisionz can help organizations apply AI-driven insights to forecast material readiness, identify recurring constraints, and support disciplined, readiness-based work release. This ensures materials management becomes a proactive enabler of predictable execution and not a reactive support function. If your workface planning is still constrained by material uncertainty, ReVisionz can help. We work with teams to align materials management, warehousing, and work packaging so execution is planned rather than improvised. Connect with us to continue the conversation, explore our materials management guide for deeper insight, or subscribe for ongoing insights.